Welcome back to the video lesson series on transducers. Today, well, for this episode at least, we're going to go on to more transducers. And so far, what we've been talking about have been like microphones and LDRs and IR photodiode, pairs, all these things. Now, if you notice, so far they have been taking, let me write this down. So far, what we've been doing is that we've been taking non-electrical signals and transforming them to electrical signals, right? So far, all we've been doing is about talking about input transducers. Now, we're going to, from this segment on, we're going to be talking about how to convert electrical signals back to non-electrical signals. So these would be your output transducers. Okay, so the first one we're going to start off is a buzzer. Now, a buzzer is an output transducer which converts your electrical signal into sound. Okay, so these are very simple transducers. All it does is that it just beeps, right? A slightly more sophisticated type would be able to beep with a different frequency, all right? But essentially all they do is just beep. And these are piezoelectric buzzers. The ones that we have, now I'm sure you have seen this in your ALP class, these fellas, okay? They are quite small, and this is the symbol. Please know how to draw the symbol for a piezoelectric buzzer. And so how it works is that when it has an input current, when there's a current, this piezoelectric plate here, this fella here, it starts to bend back and forth. And when this fella starts to bend back and forth, it kind of vibrates. And this causes the air particles here to vibrate with the same frequency. And that's what we hear, okay? So these air particles vibrating is what we hear, all right? So a piezoelectric buzzer has a positive and a negative terminal. Usually, the ones that we have the terminals marked. So this is your buzzer because one leg is shorter than the other. And as usual, the longer leg one is the positive terminal. Okay, so we usually use between 3 volts and 12 volts. Don't go below that. Anything below that, we can't really hear the buzzing. Anything above that, we might damage the buzzer. Okay, so the next transducer we're going to talk about is something called a loudspeaker. Now, this loudspeaker is also an output transducer, and it also takes electrical signals and changes them into sound signals, sound energy. So you'll be asking, what is the difference like between the loudspeaker and the buzzer, right? So the difference is that the loudspeaker is typically slightly bigger than a buzzer, and it works on a different concept. So usually it has a cone-like thing. Okay, usually it is a cone-like thing. And what happens is that when the fella receives a signal in, okay, it causes the cone to vibrate in and out of the this little coil here in between the magnet. Okay, and when this fella vibrates in and out, it causes the air particles to also vibrate with the same frequency. Okay, so a loudspeaker uh, can produce more complex sounds such as music and human voices, right? So kind of read up slightly a bit on how a loudspeaker works, and you'll actually be learning about it in your physics, all right? So this is the symbol. Please learn how to draw the symbol of a loudspeaker. Okay, however, you'll notice that we don't usually connect a loudspeaker straight up to the output because the signals that we are talking about here are pretty low. Okay, so what we need to do with these low signals is to amplify the signal. So before it gets to the output, before it gets to the output here into the loudspeaker, we need to have a sort of a amplification from here to here to boost up the signal so that the loudspeaker will be able to vibrate with enough energy. Okay, so just remember that we need a amplifier here. We seldom connect, in fact we never connect a microphone straight up to a loudspeaker. Okay, we usually have a amplifier in between them. Okay, so I'm going to stop here. That was a transducer to convert electrical signals into sound energy. Okay, so I talked about two methods. One is using a buzzer, the other is using a loudspeaker. So I'm going to stop here before going on to the next part called DC motors. Okay, so rewatch this video if you need to. If you got any questions, you can email me at yo_haig_gene@sass.sg. I'll see you in the next video.